Okay, part B on number 3 is find pK. Now, for this particular problem, I want you to go back a step or two on scratch paper. And so what I'm going to start out with is scratch paper stuff. And so I'll do that in blue. And we want to take advantage of the fact that delta G naught equals RT natural log of K. And that is equal to, oh, I'm sorry, I left out the minus sign.
There you go.
Thank you. And that is equal to minus 2.303 RT log of K. And that's equal to 2.303 RT times the minus log of K. The reason I wanted to rearrange it in that form was because the minus log of anything is what? P of that thing. And so this is equal to, this delta G naught is equal to 2.303 RT times PK. And then the other thing you can do on scratch paper, or you can probably have this one memorized, what is, so at 25 degrees C, which is the temperature for the naught denotes standard conditions, it equals 298 K. 2.303 times 8.314 joules per mole K times 298 K is equal to what? 5.7 kilojoules per mole. And so this is all scratch paper stuff. You could put the top row in and then just take advantage of the fact that this is, so I would say this is equal to 5, so delta G naught is equal to 5.7, and a 7 actually looks like this, kilojoules per mole times PK. So I don't necessarily need this on the page, that would be scratch paper. You could, if you felt compelled, to put all this in, or you could just start with delta G naught equals 5.7 kilojoules times PK. And I would accept that. But you need to know from whence it came. Okay, and it's easy to remember 5.7 kilojoules. Okay, now, so that means that, therefore, PK is equal to delta G naught divided by 5.7 kilojoules per mole equals, what was our delta G we found? 27.15 kilojoules per mole divided by 5.7 kilojoules per mole. And that was, this is why that question we had earlier. Yes, Robert?
I think you dropped a Kelvin with the 5.7 kilojoules Kelvin mole per mole. Because there's a T there, and doesn't T represent temperature?
Okay, good question. That was because it was 2.303, 8.314 joules per mole K times 298 K, and the K drops out.
Thank you.
Okay? Okay, so back to this. So all I have to do to solve for PK, which we've already got over here, so I get a scratch paper out and I go 5.7 and I divide it into 27.15, and then it's the little things. It's the little things about this that sometimes cause somebody a grief. We forget. Got to move the decimal point over, and now it's just straight up division. 57 goes into 271. We'll try 4, and I'll put the decimal point up there, and I multiply 4 times 7, which is 28. 4 times 5 is 20, so it's 22. Drop that down, and the 11 minus 8 is 3. 6 minus is 4 under 35. So I'm going to try a 7 here. 7 times 7 is 49. 7 times 5 is 35, and 4 is 39. And then 15 subtract 9 is 6. 12 subtract 9 is 3. And 360. That's going to be a 6. Okay, 6, and we don't need to go any further. So this is all scratch paper. So I've got this, and PK equals, I've already written this statement is going to be 4.76. And we are now, I can erase my scratch paper, and even this part up above I don't have to include. But if you do include it, I won't shoot you down for it. But I'm not going to shoot you down if you don't include it. I just want to have, at the very least, delta G naught equals 5.7 kilojoules times PK, and PK is equal to this. Bang, bang, and we could go equal 4.76, and that would be adequate. Yes?
And last time you said that we could use 6 to make it easier instead of 5.7?
Yeah, but at this one's easy enough to where if you get bogged down on it, I don't care that much. You can use 6, but don't rush off to do that. You know, relax and try and take your time. I'm going to try to remember to have everybody do a breathing exercise at the beginning of the test, where everybody learns to relax. Breathe in through your nose and out through your mouth, and find all the tension in your body and just let it go. A tank of healing would be good. And maybe I'll see if we can get one. But try to relax, and then don't be intimidated by any of this. Take your time. And if you start to get stuck on something, don't panic. Stop. Relax, breathe in through your nose and out through your mouth. Try to find any physical tension in your body and relax, and then go back and look at it.
Take a safety break.
What?
Take a safety break.
A safety drink?
Safety break.
A safety break. Ah.
That's safety.
Okay, yeah, we could do that. But I just want everybody to try and take your time and relax. It's again, I'm interested in how you got it more than I am the final result. So if this is a little bit off, it's going to be propagated through the next part of the problem. But as long as you're consistent, you're going to be okay. And I take away a point or 2. If it's a 5-point problem, I'll take away 1 point. If it's a 10-point problem, I'll maybe take away 2 points for a mathematical error. It's not that much. The majority of the problem is the setup. Okay, because that's really what we're trying to test. And again, I wanted you to go back to the basic statement that from whence it all came, and then know how to get here. And if nothing else, do this on scratch paper. There's not a lot of room, so maybe you just go directly to delta G naught on the page, and therefore this, and then we've got it. Okay? Is everybody comfortable there? Okay. So now let's go right on to part C. This is really, really, really a hard part of the problem.
The worst part of the whole test?
Yes, this is the most difficult part of the entire test, is find K for the process. So find.
You look at negative log land.
Yes.
I might have to take
So K, which is, what does K stand for? Kellogg's, the mass action, yeah. The mass action law. And this one is one where you can simply write, I want this information. K is equal to 10 to the minus pK. And that is equal to 10 to the minus 4.76, or whatever you found when you got there. So if you made a mathematical error, as long as you write this, that's fine. If you made a mathematical error and you write K is equal to 10 to the minus mathematical error, I'm going to have a problem. Yeah. Including this little step, because it's not, there's very little space, that's all you need to write. Okay? It reflects the fact that you are aware of how the P functions in all of our use. And we're going to be dealing with P in just a minute in the next part of the problem. So is everybody comfortable on that?
Yes, sir.
Okay. This one was probably the easiest part. Now we're going to get to part D, where we're going to have to get back and we're going to be doing some acid for a while. So this part's a little bit, yeah, we're going to hit the ice and do some acid. Okay.